Good afternoon, everybody. This is a live radar breakdown as we have a tornado warning just to the east of Mineral Point, Wisconsin. This is in southwestern Wisconsin, and I think that this has been confirmed. I was just watching some live drone video from a friend of mine, and this looked like it was touching down. Wall cloud happening. RFD was starting to surge out. So if you're in Jonesville, Wisconsin, you need to be in your safe place. Right now, certainly. This is a dangerous storm. Law enforcement confirmed tornado there just to the west of the Jonesville area. So definitely get in your safe place if you live in Jonesville, Hollandale. This is a mesocyclone. You can see very well-defined mesocyclone. Let's take a look and see if we have any debris being lofted by this storm. So far, we do not have anything right now in terms of debris, but there is a law enforcement confirmed tornado. I'm getting on here, taking a look at some of these reports. I do have some storm chaser friends that are on this right now. Confirmed tornado near the Jonesville area. Jonesdale, pardon me. Jonesdale, Wisconsin, southwestern Wisconsin. We were watching a tornado warning storm in northeastern Iowa as well, but that one thankfully has since weakened. So I'm not seeing much in the way of debris right now getting lofted up. But then again, I was looking at Davenport radar. That would be getting lofted pretty dang high into the sky. So we're going to shift to a radar that's a little bit closer. They really probably aren't that different in terms of proximity to the radar site. But there you can see the hook echo, cyclonically curved hook echo. These storms today have had a really fuzzy forward flank gradient boundary there, and I think that that's probably due to some unfavorable characteristics for the hodograph or maybe thermodynamics that usually shows that the inflow out of the southwest is not quite as strong, or at least the storm relative inflow into the storm. In this case, it would be out of the southwest, but you can definitely see this weak echo region right into Jonesdale. You're getting dominated by inflow right now into this circulation. Big hook echo. And usually storms like to move in a direction parallel to that forward flank gust front. But in this case, these storms have been moving even a little bit north of east, whereas the forward flank gust front boundary there, which usually is a pretty tight gradient for these tornadic supercells, is oriented off to the right. That's because in the upper troposphere, there are some northwesterly winds aloft. So that's why these storms look like they're southeasterly movers when in reality they're basically moving due east. This one is turned a bit to the right, as some of the tornado producers have been. So it does look like it's moving just a little bit to the south of due east. And there you can see that circulation happening. Let me take a look again and see if he has visual of the tornado right now as we're breaking it down here live. And really, the low-level jet is just a little bit displaced off to the east of these storms. And so I can keep that radar cranking in the upper right. Let me show you the environment that these storms are moving into. Nice instability axis, 5,000 to 6,000 Cape there, streaming in to this storm. There it is, just below that radar image. Now you can see northern Illinois. You can see that Cape axis there. This is the latest WRAP analysis. 5,000 to 6,000 Cape pumping into this storm in southwestern Wisconsin, and it does appear to be on a boundary with some convective inhibition with the blue coloring off to the northeast of it. Usually these differential heating boundaries can have a little bit more favorable wind shear, some weaker surface winds, and you can see right now that this storm is just about to move into some pretty favorable wind shear there in southeastern Wisconsin. You can see that the WRAP model, the latest WRAP, has initialized that storm pretty well, exactly where it is. And look at that 0 to 1 kilometer wind shear out ahead of that thing, 200 plus ramping up, and that includes the Madison area. So if you live in Madison, keep an eye on this storm. It is moving at about, 30 miles an hour. So it's going to take a while before it gets to Madison, but Realistically, we've probably got about a 2 to 3 hour window where this thing can continue to be surface based. But the wind shear appears to ramp up out ahead of this storm. We could take this forecast about 2 hours from now. Zoom out. 2 hours from now. Look at that wind shear kind of collapse into southeastern Wisconsin there into northern Illinois. That convective line kind of maintains itself right along that Iowa-Illinois border. So very realistically, that tornado threat could continue for another 2 to 3 hours, maybe even a little bit longer. But we've got that tornado threat happening right now. Breaking it down here. There you can see that tornado warning storm to the south of Barneveld, just to the northeast of Jonesdale. You can definitely see a well-defined hook echo. Even a tighter gradient here on the forward flank as well, showing that the inflow into this circulation, this tornado is pretty substantial up here. This is your forward flank downdraft where all the reds are located. That's where some big hail would also be within this storm. So let's take a look at velocity once again and see where this circulation is. It looks like the strongest rotation, gate to gate, is just to the north of Jonesdale right now. Just to the north of Jonesdale. Overall, it's a pretty well-defined mesocyclone. Let's see the motion here of this thing. Definitely due east, still moving a little bit south of east. Once these mesocyclones will weaken, you'll see them curve off to the north just a bit. That happened earlier. In fact, the whole entire storm will lift off to the north with that low-level jet. This is a law enforcement confirmed tornado. Looks like it happened, touchdown just to the northeast of Mineral Point. We were watching drone footage from the Twistor team. They had live streaming drone footage that I shared on my Facebook page, and you can actually see that wall cloud start to develop. You can see the RFD bowl starting to gust out and surge toward the camera, starting to tighten up cyclonic rotation within that wall cloud. But there it is. That's the circulation to the northeast of Jonesdale. Right now, it's going to pass to the south of Barneveld, to the north of Hollandale, but close to Hollandale, just to the north of Hollandale, Dalyville. You might be next in line. You're starting to get some precipitation right now from that forward flank downdraft. That precipitation is going to increase in intensity. Then you'll start to experience some hail there in the core of the forward flank, and you might get a little bit of some clearing with that inflow band. That inflow zone, weak echo region there. Then you might see a wall cloud, maybe even a tornado off to your west. That's kind of the sequence of events that will happen. Let's take a look at echo tops here and see how the trends are in the intensity of this storm. Definitely above 50,000 foot tops there. When you have a rapidly rotating mesocyclone, the tops of the storms will penetrate even higher into the troposphere. And a lot of times when a storm's about to produce, the tops will surge up. And then when that occlusion cuts into the mesocyclone, the tops of the storm will come down a little bit, basically as you're removing mass from the mesocyclone with that clear slot punching in. So a lot of times you'll see an oscillation in the very top of the storm. It'll ramp up just as it's about to tornado, and then when that occlusion process happens within the mesocyclone and it's occluded, that will cut into it, and then the tops of the storm will just go down a little bit, subsiding. But still a pretty big anvil, quite a bit of diffluence aloft up there, pretty crisp edges to the anvil as well. Still pretty high echo tops, pretty steady state right now since dropping from 60,000 feet during a likely occlusion process. And right now here is that mesocyclone moving due east, basically. It is pretty broad right now. Let's take a look at the correlation coefficient here of our radar data to see if we could see any debris getting lofted. Really nothing in terms of debris getting lofted. Makes you wonder if that is a valid report or not out there. Spotter confirmed a tornado. That's probably from Vince with the drone. 622 confirmed tornado located near Dodgeville, moving east at 30. Tornado 6 miles east-northeast of Mineral Point, and that was about 9 minutes ago. So right now, not any debris getting lofted by this, at least being picked up by this distant radar, but we do have quite a bit of rotation with this storm here. It's like breaking it down here live from Team Dominator headquarters. Thank you for joining me here today for this live update. Not sure if this is a smooth stream or not. Sure doesn't look like it. Not sure why that's happening on YouTube. Says that it's not receiving enough video. So right now we are tracking a tornado-warned storm, southwestern Wisconsin. The most dangerous part of that supercell is located to the north of Hollandale, slowly getting a little bit closer to the Dalyville area. But so far all day today we've kind of had this feathery forward flank gust front, the gradient to the reflectivity there. Usually if you have really strong inflow into a supercell, then you're getting a very tight gradient there to that forward flank gust front. In this case, a lot of the inflow is coming in from the backside here into this storm. And then you have your hook echo wrapping around the backside here, the precipitation northerly streaming in there. A lot of vorticity streaming into this developing mesocyclone there. So if you live in Dalyville, you may want to be in your safe place. Definitely a dangerous storm just off to your west. You're about to get precipitation increasing in intensity as that forward flank downdraft moves from west to east over your location. Start to get some hail sizes, and then the hail sizes will max out just when you're about to break out of the bear's cage. Then you look off to the west and likely we'll see a wall cloud, maybe even a tornado heading from west to east toward your location. Inflow coming in from the southwest into this storm. Excuse me. Hook echo wrapping around on the backside there. Sometimes with tornadic supercells, you can even get hail wrapping around in the hook and wrapping all the way around the tornado. You can get little sheets of hail that will wrap all the way around the vortex. Many times that I'm trying to intercept or do hook slice maneuvers from the backside of the storm, punching through all that rain and the hail, moving from north to south around the backside of the tornado. I'll even see sheets of large hail rotating all the way around the tornado. So when I try to open my window to hang out the camera outside of the car to videotape the tornado, a lot of times will get hammered by hail left to right. And here is that weak echo region in the reflectivity right about there. Tornado would be pretty close to the northwest quadrant of that little dry punch there. Decent supercell storm. Mesocyclone on the backside of it. I did see drone footage of the evolution of this. It did have a nice RFD, horseshoe shape RFD. Not the most well-defined clear slot, some low scud as well up there, but this is a well-defined mesocyclone that is certainly capable of producing a tornado. In Milwaukee here, we're using the Milwaukee area radar, basically between Milwaukee and Madison, but these bright blue colors are winds, strong winds toward the radar within the RFD. These are storm relative easterlies there, away from the radar. In the northern portion of that, well, basically sampling the differential motion created by the rotational motion there of the mesocyclone. So you're basically looking for a couplet pattern here. Bright colors right next to bright colors, and you want to see if they're relatively robust. If they're also associated, robustness means that the RFD, for example, is represented by multiple pixels, and then the gate-to-gate pixels are maxed out. Inflow will a lot of times be represented by a big cluster of pixels as well. So if I had to guess, I would guess that this tornado is not on the ground right now, and they may let this thing expire. But it does have a well-defined mesocyclone. It's possible that once it reaches that stronger wind shear just off to its east with that 200 plus 0 to 1 kilometer storm relative helicity, once it reaches the western gradient of that, then it could just become a tornado producing machine. So locations like Dalyville, Primrose, Belleville, there's our extended tornado warning all the way through the Verona area as well. Let's see if this warning has been downgraded to radar indicated, but it is still a tornado warning extended off to the east. We are breaking this down in southern Wisconsin. Usually this would kind of signify an unfavorable shape to the photograph when this looks like it should be moving off to the southeast, but the actual storm is moving from west to east. And I think that a lot of those northwesterlies are in the upper part of the troposphere, up above about 300 millibars. Those northwesterly winds are taking hydrometeors downstream like this, whereas the winds 500, 400 millibars all the way down through 850 are westerly or southwesterly. So the average causes these storms to move from west to east, when I think that they would have more favorable tornado production if they were moving a little bit more southeasterly. Then you would see a sharper gradient to the forward flank gust front. You'd likely see a more well-defined weak echo region as well. And this one is also a radar-indicated tornado, capable of producing a tornado located 7 miles north of Blanchardville or 10 miles southwest of Mount Horeb, moving east at 30 miles an hour. So normally, if a storm is moving parallel to the gradient in the forward flank gust front, that's the most favorable. That means that the wind shear is lined up quite favorable as well. So if this supercell were moving due south, I think you'd have a much more crisp forward flank gust front boundary there. Well-defined hook echo as well, and I think that it would be a much more efficient tornado producer. So I think that's why this thing is not producing big-time tornadoes just yet, even though it does have a pretty deep and well-defined mesocyclone there just to the west of Dalyville, Wisconsin. So thank you guys for joining me here for my weather report. Looking at a well-defined mesocyclone here to the west of Dalyville in Wisconsin. This is all the RFD blast here. So all of that blue coloring, that's all wind toward the radar. Strong RFD wrapping around the southern side of that mesocyclone. Dalyville, you want to be in your safe place all the way through Mount Vernon out there. I do suspect that this storm is weakening a little bit as it moves from west to east. But that warning does include Verona as well. There you can see the mesocyclone, storm relative easterlies of the north side, and it looks like that mesocyclone is weakening even more on the last couple of scans here. Yeah, I think that just these last couple of scans have shown this mesocyclone weakening just a little bit. I look at the correlation coefficient, and I'm not seeing much in the way of debris getting lofted by this tornado. Dual pole radar allows you to discriminate between raindrops, droplets, and the debris, even leaves that get lifted by a tornado moving through a deciduous forest. That debris is even larger than the raindrops that surround it. So this correlation coefficient product can tell you when you get slightly larger particle sizes like leaves or debris that will get lofted. And I'm not seeing anything right now in terms of debris getting lofted by this storm. And it looks like that mesocyclone is really weakening as it's lifting to the north of Dalyville, Wisconsin. It looks like just a little bit of an RFD pop is left there to the northwest of Dalyville. The blues there, that's where that little RFD surge is located. And that was once the RFD around the southern side of that tornadic circulation. And now it's just a little gravity wave or density current lifting off to the northeast. And I just got a message from Vince, who is providing ground truth on this storm, and he says that the storm is falling apart and weakening right now. So looks like even though this tornado warning is continuing, this storm is all messed up. Look at all of these hydrometeors and precipitation off to the south. Basically, it's raining in its inflow. It's supposed to be coming in from the southwest here, and looks like that hook is getting a little bit less organized. It's almost starting to pivot a little bit to a more unfavorable configuration. So I do think that this storm is starting to weaken as it's still moving from west to east. It's almost turning into a little bit of a bow echo here, just a little mini bow echo moving from west to east. It is going to pass to the south of downtown Madison. You can see this really populated area there. That's Madison, Wisconsin. And this storm is going to pass to the south of Madison, it appears. But it is definitely weakening and kind of turning into a little bit of a a bow echo there, kind of a small bow echo as it moves from west to east. And it is going to pass to the south of the Madison area. Just took my medicine. South of Mount Horeb there as well. But if this were producing a tornado, it would be happening right there, well to the southwest of Mount Horeb. You can kind of see in general some cyclonic spin still remaining here. Still does have that mesocyclone. But really that low-level rotation is really weakening with this thing to the point that I'm about to shut down this live. But if there were still a tornado, it would be to the north of Dalyville. But this thing is not a very well organized storm right now. Does appear to be falling apart on approach to the Mount Vernon area. Zooming out, let's see how some of those storms look like in eastern Iowa. Not looking very favorable either. They are sub-severe storms right now. The only tornado warning right now is located to the southwest of Madison, and that storm seems to be weakening quite a bit. This storm was tornado warned well to the northwest of Dubuque for a little while. I think that was northwest of Dubuque, like out in this area maybe. But that storm was tornado warned. Didn't produce a tornado. It did have some pretty good rotation for a while. And now we've got this severe thunderstorm warning out here to the west of Racine. And that's a weird shaped storm. Really damaging straight line winds are the only impact with that storm as it's heading west to east toward Racine and Kenosha. It'll probably propagate a little bit toward the south, wanting to propagate into that deeper moisture just a little bit. But some of the models, the short fuse models, are showing like around 7, 8 p.m. that this convective line will reinvigorate a bit as it settles in toward the Illinois-Wisconsin border. And it's possible that that convective line could even be a little bit closer to the low-level jet as well. But so far today, the low-level jet has been displaced from the convective line quite a bit with a convective line back here. Low-level jet displaced off to the southeast, so these storms really weren't able to sample that strong low-level shear during the day today. But it is possible that this evening, 7 to 9 p.m., maybe this convective line could settle in a little bit further south and then be closer to that stronger low-level shear. But by that time, then you start getting convective inhibition building in the low levels of the atmosphere as you're losing daytime heating, and then those storms will gradually become decoupled from the surface, the good deep moisture and hot temperatures. There is a severe thunderstorm warning to the north of Muskegon up there. Windbag event, damaging straight line winds, mainly heavy rain out there, 40 to 50 mile an hour type winds. I don't really see these as being that dangerous of storms here on the Michigan side, on the other side of Lake Michigan. Maybe some flash flooding, lightning associated with those, some dangerous lightning. These I'm sure would be dangerous if you're in a pontoon boat or really any boat over central Lake Michigan. We got special marine warnings issued there. And then that severe thunderstorm warning, Kenosha to Racine off to the west. So thank you everybody for tuning in to my weather reports. If this thing did have a legitimate tornado potential still, I would keep going, but it does look like it's weakening rapidly to below severe limits. So thank you everybody for tuning into my weather reports. Hopefully this wasn't too slow here as well, this live stream. Hopefully it was a little bit smoother than the image. It does look a little bit choppy. I wonder if that's because I'm streaming at 30 frames per second. Who knows? But thank you everybody for tuning in to my weather reports. I've been couch chasing this Midwest setup, but I do plan on getting back out there in the field, maybe chasing Tropical Storm Fred. That could be in the eastern Gulf of Mexico toward the later portion of this weekend, early next week.